We will use chain rule in finding the derivatives of these functions or composite functions that we have here right now. So on the first problem, we have y equals 3x minus 2x squared raised to the third power. So in this case, we have a composite function wherein f of x is u cubed, and we can say that g of x is going to be our u, which is 3x minus 2x squared. So in this case, we will be using the chain rule to find the derivative of this function. So y prime will be the derivative of u cubed, which is parenthesis cubed. We'll have 3, copy the inside, raised to the second power, and multiplied with the derivative of 3x minus 2x squared. So on the second part of our derivative, y prime is simply 3. So we are just going to copy our the first half of our work and take the derivative of the insides, which is 3 minus 4x. So the derivative of problem number 1 is simply this function over here. So that is how we use the chain rule in differentiating composite functions. Now let's go ahead and answer problem number 2. Number 2, we have f of x, third root of x squared minus 1 squared. So every time we take the derivative of a radical function, we always modify our f of x. Using the law of exponent, we can change this radical form into exponential form. So we'll have x squared minus 1 raised to 2/3. So we have another composite function over here. So we'll go ahead and find the derivative of parenthesis raised to 2/3. So f prime of x is equal to 2/3 x squared minus 1. And we know that 2/3 minus 1, which is 3/3, is negative 1/3. So this is negative 1/3. Multiplied by the derivative of the inside, which is x squared minus 1. So in our next stage of the chain rule, we will copy this, which is 2/3 x squared minus 1 to the negative 1/3, multiplied by the derivative of x squared minus 1, which is simply 2x. So this is now our derivative function, but we can still further simplify this by changing it into a radical function because we have a fractional exponent. So we can have f prime of x equal to 2 times 2x all over 3 times third root of x squared minus 1. So this 2 terms right here will be the denominator, and 2x will be in our numerator. And we can further simplify this into 4x all over 3 and third root of x squared minus 1. So that's problem number 2. Let's go ahead and answer problem number 3. So number 3, we have f of x is equal to negative 7 all over 2x minus 3 squared. Now we can have two options in how to answer this problem. We can use the quotient rule, or we can modify the function so that we can just use the power rule to find the derivative of this rational function. So I'll go ahead and modify this function by changing the denominator into a negative exponent, so I can just use the power rule. So f of x is negative 7 multiplied by 2x minus 3 raised to negative 2. And in this particular chain rule, I will use the derivative of constant multiplied with a function. So what I'm going to do is set -7 aside and take the derivative of 2x minus 3 using the chain rule. So we'll have -7 multiplied by the derivative of the composite function will be -2 times 2x minus 3. -2 minus 1 is -3 multiplied by the derivative of 2x minus 3. So to simplify our function, -7 will still be here, -2 will be here, and 2x minus 3 will also be here, but the derivative of 2x minus 3 will simply be 2. So this is now our derivative function. But if you want to further simplify this, we can combine the constants. So f prime of x is equal to positive 7 times 2, which is 14, times 2 is 28, multiplied by 2x minus 3 raised to the -3. Or we can modify this by changing the negative exponent into a fraction. So we'll have 28 all over 2x minus 3 raised to the 3rd power. So this is how we can use the chain rule in finding the derivative of this rational function over here. Now for problem number 4, we have f of x equal to x squared 1 minus x squared. So we have another radical function over here, and we have product of two functions. So our modified function can be rewritten as x squared multiplied by 1 minus x squared raised to 1/2. So in this function, we'll be using the product rule to find the derivative of problem number 4. So let's go ahead and take f prime of x, which is the derivative of the first. So I'll have 2x. I'll copy my my second term, add it to the copy of my first term, multiplied by the derivative of the second term. So we'll have 1/2 1 minus x squared. 1/2 minus 1 is -1/2, multiplied by the derivative of the inside, which is -2x. So now that we have the derivative of the function using the product rule, we can simplify this term and this term over here. So our f prime of x, if we're going to simplify the first group, is simply 2x square root of 1 minus x squared. And the other group, we can simplify it by simplifying the product of 1/2 and -2x, and we'll have negative x all over -1/2 can be rewritten as square root in your denominator minus 1x squared. So if we want to further simplify this answer, f prime of x is 2x square root of 1 minus x squared minus x all over the square root of 1 minus x squared. So this is how we use chain rule in finding the derivative of composite functions.